Certainly it does. And we're already starting to see this come through on the, we'll say, the accessory side of things, so light duty applications where the regulations still allow it. And so I think it's going to take some time until the technology matures enough to put it into automotives, and it'll actually draw some inspiration from aerospace. Right? So as aerospace processes become more and more validated, it has a trickle-down effect to automotive. And so we'll see some of these processes into commercialized vehicles on a light-duty scale, probably in the next 3 to 4 years, and I think it's just going to start coming more and more. We're talking about printing direct to part, right? And then the next talk is about 3D printing tooling or molds, right? So that'll become much quicker, I think, also in the same time period. We're working with that now at Local Motors, but we're also looking at implementing technology into aerospace now, and so I think it's just a matter of time before it hits automotive, and it'll hit quicker because it has less requirements. So tooling, if it's 3D printed, it just kind of sits there more or less, right? So it won't be crashed into, hopefully. So you'll see application of parts that are thermoformed or made by composite manufacturing processes much sooner. So Ali originally came from wanting to solve a mobility congestion problem for the city of Berlin in the year 2030. It was actually a sponsored project. That's where the idea came from. And so we use a model called co-creation to help source solutions, and both for design and technical, where we go out to the entire global community with an online platform and say, how would you solve this problem? And so this design actually came from a gentleman that was one of our community members. And so he was a South American gentleman going to design school in Italy, solving a challenge for Berlin. Right? So he crosses the world in this one person, right? But his original idea was actually the Ali, and it was actually originally called the Berlino, was the first concept. But it was about a mobility system and numerous vehicles coming together to form on-demand electromobility solutions. And so it evolved from there, and we kind of took the reins and built an MVP, a minimum viable product, and we found out that there was actually a lot of demand for this sort of product in the market. And so through there, we've used our direct digital manufacturing processes, or 3D printing, to help build a vehicle in a short amount of time. So the first ones we put to the market to bring it to the public for first riding only took about 6 months. And that was electric, 3D printed, low-speed vehicle, right? So a lot going on there, and it's autonomous, right? So a lot of technology had to come together relatively quickly, and that's pretty unheard of in automotive development. And so now our challenge is how do we bring this vehicle to market for our now pilot programs, but then going forward into our commercial deployments. And that's where really the challenge presents itself when we start looking at bringing these polymer composite 3D printed vehicles to the market. Certainly, especially in urban areas at first, or campus-type environments, because it's a shared mobility ecosystem. And I think everybody that's even on the panel today, later on, has some sort of idea that this shared mobility revolution is coming, and it's starting to hit now, where there's less and less people owning vehicles. It's more of a subscription model or a leasing model, and it's more democratized transportation. And so it's coming, and the adoption rate's going to be there. And I'm a car guy. I'll never not have a car. But that's just me. I'm a fringe use case of the past, right? But as the youth comes to their driving ages, less and less of them will have a license, right? Or maybe not until later in their life. So I think this sort of shared mobility is an eventuality. So if we want to talk about competition, we believe that Ali is the most sustainable from an ecological perspective, but also it's the most able to be advanced. Right? So because of the methods we use with digital manufacturing, it means we can keep the pace of all the technology partners that are within the vehicle. So LiDAR, radar sensors, autonomy software, EV components like batteries and drive motors. These things are changing in price, size, efficiency at a 6-month pace, right? And if you're talking about traditional automotive development cycles, it's 5 or 7 years on average, right? So that means you're waiting that time period to have a change in the product itself. Well, we're willing to do that, every 6 months, every year. Mm-hmm. So that means you're always going to get the best performing product with the best safety features and the best reliability at a given time. So I think the big challenge everybody's after using polymer composites. So whether traditional thermosets with composite or thermoplastics, they have a little bit different challenges. I think we're getting pretty mature on thermosets and composites, but on thermoplastics we're a little less mature aside from body panels. Right, those are pretty well understood. But now you have more polymer composites. If you start talking about structural, even crash structures and or vehicle panels or major body parts, there's probably a lot more work going on around the fiber content, because it's actually probably 70% of the cost of the commodity compounded product. So there's a lot of, as technology gets there to bring the cost of that fiber down, it brings the actual polymer product cost, the end cost down. And so they're looking at recycled fibers, low energy ways to produce these fibers to go into the compounded polymer itself, right? But we always want to maintain that sustainability element, right? That's important to the global folks looking at sustainability and or the environment, and as well as to us as OEMs, right? We need to be looking for that and making sure that we're closing the loop on anything we're putting into the market, so we can come back and recycle it and repurpose it again. And now you're talking about getting into the realm of vehicles or vehicle components made of one polymer, right? Yeah. That massively changes even the distribution system and your supply chain around that product, right? So now you had maybe 20 different polymers in a vehicle. Well, if you reduce that to maybe 2 or 3, that makes the job of recycling much better, right? And so I think you're going to have a lot of motivations happening, pushing that from governments and other regulators to help make that happen. So I think we'll get there. It's just a matter of reducing cycle time to produce these parts, and then also making sure we're still making them in an economically responsible way too, so we can put products to market that people can afford to buy. Here's the curse. So I've been with the company for 3.5 years. I still have not printed anything for myself. And you would think I would have the chance to, but that's still not the case. And so I think one of the first things I would print is actually a piece of architecture, architectural seating. And it's just because of my background as an industrial designer, I look at the product side of it. But I'd probably do that, or maybe something like I printed like a shifter cart or like go-kart. So something I can get in and drive and have fun with. Those are probably the things I would print. Well, so our challenge right now is trying to bring a 3D printed monocoque type structure to the market in a validated way. So we just finished up our first round of crash testing, the first of its kind on a 3D printed structure for polymers. So we're collecting the learnings from that, and that's going to inform some of our next steps developmentally, and see where we're going to put this technology, hopefully into ALDI in the next 16 months is what we hope. And beyond that, now once we've validated the process and the materials, then the world's our oyster, as they say, right? So anything is possible right now. So that we now know that we can validate this technology and put it towards any other mobility solution. So it gives us a lot of flexibility to look at new applications in mobility. And so we already have interest from different military groups and other low-speed electric vehicle type markets.